As per this morning's keynote talk, my name is Matt Bidwell and I am 6'3". So we have spun up a new system at NREL. NREL is the National Renewable Energy Lab. We are the sole lab totally funded by the DOE Office of Energy Efficiency and Renewable Energy. That's a little joke. We didn't submit to the top 500. Number 2 on a list that doesn't exist is a little more impressive than number 40 on a list that does exist. So this is our brand new state-of-the-art building. This is our office space. This big black box is our data center. This is a lab space designed to do electrical work at grid scale. They had to quadruple the power to our entire campus just for this building. Up here we have some evaporative coolers. That's actually how we cool the building. We don't have any traditional air conditioning systems in the building. Everything is done with closed loop water being chilled with evaporative cooling. So we have no traditional crack units in our data center. It's all actually 75-degree water, which we consider warm water. And we use that water that comes off the systems that's 95 degrees to go back into the building systems to heat the building. So what we sort of talk about is total system integration, and the HPC system is a part of the building system, and it heats the building in the winter. And it's also integrated with the rest of the building's cooling systems. Here's our hot aisle containment system. This is all our traditional air-cooled equipment. About here over is HP provided HPC equipment. We've got 2 racks of Luster, another rack over here, and another home file system, some traditional air-cooled compute nodes. And then over here is sort of our more traditional database servers, smaller clusters, and that type of stuff. We lost our original data center sometime in the spring, so we took that as an opportunity to chuck a lot of our old equipment. It was inefficient, took too much air load. But right now, this is the entirety of a 10,000 square foot data center. This is the entirety of the air-cooled stuff. This is the DOE secretary trashing our new machine. All of this is water-cooled equipment. What we have is basically 2 racks of a brand new water-cooled architecture from HP. And in between, we have a pump rack in the bottom and a network rack in the top that holds a big Mellanox switch. Our OS is CentOS. All our nodes are completely diskless. That's an asterisk because we do have a couple of disks in order to make images for nodes. We're using HP's OneSys, which basically will take a disk-full image and make a diskless out of it. In order to serve that out, we're using CMU to make the images from HP and OneSys to deploy them. OneSys is a lot sort of more lightweight than actually using CMU to deploy the images. CMU sort of allows too much write back to like an originating file system. We rather keep stuff in RAM and keep the network clean of all that write-back traffic. So there's not a lot of stateful stuff happening in the images. And this is why I'm in this booth. We use Moab and Torque. Here's sort of a breakout of the machine. These are those air-cooled nodes. And they were sort of our first delivered test nodes. Then we've got 3.5 racks of 24-core Ivy Bridge with 32 gigabytes of memory. We've got another group of fat memory nodes. And then we've got another set of racks with the PHYs, 2 PHYs apiece installed in them. So we did something called a scalable unit, which I guess a lot of other people are talking about. In our case, a scalable unit is a fully subscribed group of nodes where the IB fabric, is a 1-to-1. And then going up to between those scalable units, it's a blocking fabric. We have sort of a young user base, and they don't have young as in not age-wise, but young to HPC. So we didn't have a lot of people who were going to run outside of 288 nodes. So we sort of decided to make these really good blocks of fully subscribed nodes, and if someone had to do sort of bigger jobs, they'd have to actually come to us and negotiate to do those. Hold on. Okay. So, and through Moab, we're actually containing people to 288 nodes. That's a feature in Moab you can use. Right now, we're sort of in an early access mode. So we're doing sort of fair share. We have 50% of the machine allocated for a few big science projects that are supposed to get big results early on. Then 33% of the machine is some other early science applications. And then everybody else is fighting for 17% of the machine. The nice thing about fair share is if it's empty, you're not really fighting. But if someone who does have that 50% allocation comes in, they can come in and jump in front of you in the queue. Another Moab feature we're using is we sort of force people onto we queue them up on the 24 core nodes, but they can request a feature for either the 64 gig, the 16 core, or we have something called any, which means they'll get on the first group of nodes available to them. And some people will either just program it for 16, and if they get on a 16 or 24, it doesn't matter, or some of them have some logic into their code that will figure out what kind of node it landed on. We do have turbo on as a default, but a user can also request that Moab turn off turbo if they need it. So we do most of our heavy lifting of sort of cleanup or turning things off via the prologue or the epilogue. For users, sort of as part of their job, writing tiny files that they don't actually have to write back to a file system, and there's a lot of them, they end up writing it to DevShem, which is sort of an in-memory file system. I think it was sort of originated with Cray. So you see it in Cray and SGI systems. But so we have the epilogue cleaning up the sort of temp and DevShem areas. We recently added a program called Reaver that I think started at Ohio's Supercomputing or OSU. I'm not sure which. It now resides at Nix because it sort of moves with Troy. And we've been really happy with that. Stuff that was supposed to get killed and doesn't get killed, Reaver will come in and kill up the processes so that you don't have stuff running on a node when the next user starts, which is a big deal for, like, say, Gaussian users who are sort of allocating every little bit of memory they know they should have, and so if there's another process running on there, their job dies. And with Gaussian, it's usually a one-node job, so about 50 of their jobs will die in a row because it keeps landing on the same node because it doesn't have all the memory it's supposed to. We're also using Werewolf node health check. It catches a lot of IB degradation for us, and we'll mark the node offline when it sees something not performing as it should. So our future implementation. January 1st, we've told people that we're going to go over to an allocation, so I think Friday they all had to have their requests in. Surprisingly, we got a lot of requests for accelerated nodes. Either our users think there's something different than they are, or our users are a lot more advanced than we are, because we don't have anything but Wharf ready to run on accelerated nodes. So in the next month, we'll be sort of implementing an allocation scheme, and then we've got to sort of get the PHYs integrated, which I think a lot of people here need to do. We can run code on them. They're fine as a standalone machine. We can get Torque to recognize them. There's just a whole kludge with actually having Torque make it so users can actually use the PHY they're assigned. And there's a couple problems, like, well, you could do it where the compute node that the PHY is on allows access. But then if the person wants to book the PHY in like Torque or Moab and SSH directly to there, how do you do that? So we still have a lot of work to do with this. Here's some links. This is our website, which has lots of information about the machine, some of the stuff we do. People ask me what kind of codes we run, and I tell them everything but storm surge and bioinformatics, basically. With with the energy efficiency and renewable energy, we got a lot of wind codes, fluid dynamic codes, chemistry codes, just all over the place. Buildings codes, because of a lot, the energy efficiency thing is a large part of what we do. All our buildings are labs. I am the beneficiary of being the last building we've built on campus, because they fixed a lot of problems they experimented with in the other buildings that didn't pan out. Here's a link for Werewolf Health Check, and a link to Reaver. If you haven't seen it, I recommend looking at it. Questions? Anyone want to know why something spelled PHY is pronounced Mike? Anyone? Also, we're hiring. We've got a scientist position, an admin position open. Come and talk to me. That's about all I had.
All right, thanks, Matt. Bidwell, give him a hand.